Hello and welcome. So we'll be solving another interesting question. All right, if you look at this beam, we have a hinge between AE and what EH, right? All right, so we are going to break this into two parts. Do you understand? We are going to break this from here. That is AE and EH. All right, so it means we are going to be redrawing this diagram here. So, and don't forget, here we are given 7 at 1400 mm is equals to 9800 mm. It means that we have 7 space. We have 7 space, which is what? AB, BC, CD, DE, EF, and FG, and what? GH. If you count them, 1, 2, 3, 4, 5, 6, 7. We have 7 space. So it means each of this space is what? 1400 mm. So if we multiply 7 times 1400 mm, we're going to have 9800 mm. So it means that we can take this to meter. If we take this to meter, it's going to be what? 1.4. Is that clear? So it means each of this line is going each of the distance is what? 1.4, and they are all what? Equal. AB is equals to BC equals to CD, and so on and so forth. So we are going to redraw this diagram. So this is what our diagram is going to look like. We have break the beam into AE and what? EH. So, and the reason why our E, if you look at point E here, where we have the hinge, you know, for two things to come together, do you understand? For two things to come together, just like a magnet, for us to have two magnets to come together, we must have the positive pole and the negative pole. Is that clear? So that is why when we break this, we have an upward force here, then we have a downward force here. You can decide to put your upward force here, and you can put your downward force here. Anyhow you are doing it, you are still correct. Is that clear? All right. So now we are going to be drawing our diagrams here, then our calculation at this side. So let's start with the first beam, which is EH. All right, so beam EH. So we are going to be starting with the summation of all the upward forces. Summation of upward forces is equals to what? 0. All right. So here we are taking upward force positive, downward force negative. So we are going to have R subscript E plus R subscript H to be equals to the sum of the upward force. 300 plus 40 is what? 340. So this is our equation number 1. So for us to get the second equation, we are going to take moment about point E. So the sum of moment about point E, the sum of moment about point E will be equals to what? 0. So it means if we do that, we are taking our upward force positive. So it means ROH multiplied by the total distance, which is what? 4.2. So ROH multiplied by 4.2 minus 300 multiplied by what? Multiplied by 2.8, because it is from this point to this side. Don't forget, force times perpendicular distance is force here to this distance, this force here to this distance, this force here to this distance. So it's going to be minus what? Minus 40 multiplied by what? Multiplied by 1.4. Everything will be equals to what? 0. So 4.2 times ROH is going to give us 4.2 R subscript H, and 300 multiplied by 2.8 is going to give us what? 840. So we are going to have minus 840 minus 40 multiplied by 1.4 is what? 56. So we are going to have 56 equals to what? 0. So 4.2 ROH will be equals to minus 840 minus 50 minus 56 is what? 800 and what? 96. So if we move that to the other side, we are going to have 896. So if we divide both sides by 4.2, this will go with this, then our ROH will be equals to 896 divided by 4.2, that is 213.33. 213.33 Newton. All right, so we are done with our ROH. So let's get our ROE. So our ROE will be equals to, from equation 1, 340 minus our ROH, and our ROH is what? 213.33. 3.33. So if you press this in your calculator, you are going to have what? You are going to have 340 minus 213.33. You are going to have 126.167. 67 Newton. All right, so that's what we are going to have. So we are done with the first beam. So let's go for the second beam. So beam AE. All right, so again we are going to be considering the summation of all the upward forces. The summation of all the upward forces is equals to what? Or 0. Sorry, the summation of all the vertical forces will be equals to 0. So upward force positive, downward force negative. All right, so the upward force we have here is ROD and what? ROA. So we are going to say RO subscript A plus RO subscript D will be equals to the downward force that we have here are 3. 300 plus 300 is what? 600. So 600 plus ROE. What is our ROE? That is 126.67. All right, so if we add that together, we are going to have ROA plus ROD to be equals to 726.67. So let's call this one equation number 2. All right, so the next thing is we are going to take our moment about point what? About point A. So if we do that, we take moment, summation of moment about point A to be equals to 0. So if we stand at this point, this first one here, don't forget this is a downward force, it's going to be negative, right? So ROE, our ROE is what? Minus, we are going to have minus 126.67 multiplied by the total distance. The total distance here is 1.4 plus 1.4, that is 2.8. 2.8 plus 2.8, that is 5.6, if I'm not mistaken. Yes, 5.6. So multiply by 5.6. All right, so now let's go to the next one. This is ROD. This is going to be plus, because it's upward, ROD multiplied by what? The total distance here, 1.4, 1.4, that is 4.2. All right, then minus, we have another downward force, 300 multiplied by what? 2.8. Then minus what? Minus 300 multiplied by what? 1.4. Everything will be equals to what? 0. All right, so if we continue with this, we are going to have this. So 126.67 multiplied by what? Multiplied by 5.6. We are going to have this to be what? 709.352. All right, 352. All right, so if we multiply this by 4.2 by D, we are going to have 4.2 RO subscript D. All right, so 300 multiplied by 2.8, that is 840. So we are going to have minus 840. All right, minus 300 multiplied by 1.4 is what? 420. So we are going to have this to be 420 equals to what? 0. All right, so by the time you sum this with this and this, that is this minus this minus this, you are going to have nothing but what? 1900 and what? 69 point what? 0.352. 1969.352. 0.352. Then we are going to have plus 4.2 ROD equals to what? Sorry, this will be negative. This thing All right, so we are done with calculation of the reactions. So this what we get. So we have arrow A, arrow D, arrow H, arrow E here. I'm supposed to have write them here, but it will be cluster. You understand? And I want a neat work. All right. So now the next thing we are going to be doing is to calculate for the shear force. So we are going to be starting with the shear force of this first beam, which is EH. All right. The shear force. Shear force calculation. All right, so let's start with that first part there. So let's start with the shear force at point H. Shear force at point H will be equals to, now we are still using upward force, positive, downward force. Now if you start at this point, the only force you are going to see to your right hand side is just this one here, which is upward, so which is arrow H. That is the reaction at H, and the reaction at H is what? 213.33 Newton. All right, so the next one, the shear force at point G. The shear force at G. Shear force at G will be equals to, so if you stand at point G to your right, you are going to be seeing this and this. That is 213.33 minus what? Minus 300. So if you subtract this from this, the shear force at point G is going to be what? Minus 86.67. Minus 86.67 Newton. All right. So the next one is shear force at point what? Point F. All right. So since we know the shear force from point at point G, so for that of point F is going to be, you know, it is a downward force, right? So and that of point G is what? Minus. So it's going to be minus 86.67. Then minus what? Minus 40. You know, if you stand at point H here, you are going to have these three forces, 1, 2, 3. You understand? So this is positive minus this minus this. So instead of us repeating this, and then you now put this, it's just better you write the answer, then you subtract from the next one. So if you do that, we are going to have the shear force at point F to be equals to minus 126.67. Minus 126.67 Newton. All right. So the shear force at point E now. The shear force at point E will be equals to, all right. So if you stand at this point now, if you stand at this point E, and you want to take your shear force here, and that is going to be, since we know our shear force at F here is nothing but minus 126.67. All right. So if you start at point E, we are going to be seeing four forces, right? 1, 2, 3 was this upward force. So and our arrow H, our arrow E rather, our arrow E is the same thing with this number. So plus 126.67. So this will be equals to what? 0. All right. So now the next one is the shear force for this next beam. So let's start with point E there. So the shear force for point E here, this is for this other beam. Do you understand? Take note of that. For this other beam. So for this other beam, the value at point E here, we have a downward force, and which is arrow E. So our arrow E is going to be minus 126.67. All right, so that's going to be the value that we have. So the next one is the shear force at point D. The shear force at point D will be equals to, if you start at point D, we have two forces to our right hand side, this and this. So it's going to be arrow E minus arrow E plus what? Arrow D. That is minus 126.67 plus what? Plus our arrow D. Our arrow D is what? Our arrow D is 196 what? 1969 point what? 352, which will be equals to, if you do the math, you are going to have your shear force at point D to be what? 342.22. 342.22 Newton. All right, so that's what we are going to have. Now, we are done with point D. So the shear force at point C. The shear force at point C will be equals to, so at point C, since we already know the shear force at point D, which is what? 300 and for 42 point what? 0.22. So the shear force at point C now, we are going to minus this from this. So we are going to have minus 300. So if you subtract 300 from this, you are going to have your shear force at point C to be equals to, sorry please, when we are dealing with the calculation of our reactions, we're supposed to divide this answer by 4.2. Sorry, I keep on repeating it. When you divide this by 4.2, you're going to have the reaction at D to be 468.893. Sorry please, this reaction at D is going to be, so I'm going to be making necessary corrections. All right, so we are going to be putting 468.893 here. Sorry for the mistake. All right, 468.893. All right, so if you do the math, you are going to have your shear force at point D to be equals to 300 and what? 342.22. 342.22 Newton. All right. So that's it. So the shear force at point C. So I think that is the shear force at point D, right? So the shear force at point C now is going to be 342.22, then minus what? 300. So by the time you do this math now, you are going to have your shear force at point C to be equals to what? Equal to 42.22. All right. So now the next one is what? Point B. So the shear force at point B will be equals to, since we already know that of point C, which is 42.22. So the one of point this, we are just going to minus 300 from this. So this will be equals to the shear force at point B here is going to be what? Minus 257.78. Minus 257.78 Newton. All right, that's what we are going to have. Now, the last but not the least, the shear force at point A. The shear force at point A, if you do your math very well, you are going to have this one as a downward force, and minus RE plus RD minus 300 minus 300. Then if you add it with what we have here, you will definitely get what? 0. So this will be equals to what? 0. All right. So the shear force at E2 is what? 0. All right. So now the next thing we are going to be doing is our what? Our moment. So I want to drink water. So now the next thing we are going to be doing is the bending moment. So let's go for the bending moment. Bending moment calculation. All right, so the bending moment calculation. Now let's start with this first bit. So we are going to be starting with the bending moment at point. The bending moment at point H will be equals to what? 0, because here we only have force, we don't have distance to the right. So the bending moment at point G now, bending moment at point G will be equals to, if we stand at this point G, we are going to have this force with this distance, so which is going to be what? An upward force. So it's going to be ROH, and our ROH is nothing but what? 213.33 multiplied by the distance, which is what? 1.4. So if you do this, you are going to have the bend moment at point G to be equals to 298.662. 298.662. This will be what? Kilonewton meter. Kilonewton. Sorry, this is not kilo. This is just Newton. Sorry. This is Newton meter. All right. So now bending moment at F. Bending moment at F, point F, is going to be ROH multiplied by the total distance here. Now our ROH is an upward force, which is what? 213.33 multiplied by the total distance, which is 2.8. then minus what? Minus 300 multiplied by what? 1.4. So if you do the math, you are going to have your bend moment at point F to be equals to 177.324. 177.324. So this is also in what? Newton meter. All right. So the bending moment at point E. The bending moment at point E now. All right. The bending moment at point E will definitely be equals to what? 0. If you do it, if you stand at point E, ROH multiplied by the total distance minus 300 multiplied by the total distance 40 multiplied by the total distance, you are going to get 0. You can try that out. All right. But this is a simple supported beam. Do you understand? And the bend moment at the end of a simple supported beam is what? 0. So you don't need to solve that. You must always get 0. All right. So now let's go for the next beam. Bending moment at point E. All right. The bending moment at point E here is going to be what? 0, because to the right we don't have we only have force. We don't have what? We don't have a distance. So this is going to be equals to 0 as well. So the bend moment at point D now. The bend moment at point D will be equals to, if you stand at point D, this downward force, that is minus 213.33 multiplied by what? 1.4. So that is going to give us what? Minus 298.662, because we've already solved that here. So that will be the bending moment at point D. I have made an unforgivable mistake. All right. This is a bending moment at point D. This is point D here, not on this other beam. Please don't do this. So at point D, we are using reaction at what? At E. So this is supposed to be what? 126.67. All right. All right. All right. So now at point D, we have our ROE, and our ROE is nothing but 126. 126. But don't forget, it's a downward force. It's going to be minus 126.67 multiplied by what? 1.4. So if you do this now, your bending moment at point D is going to be what? Minus 177.338. Minus 177.338. All right. So now the bending moment at point C now. Bending moment at point C will be equals to, so we stand at point C now. We're going to have a downward force multiplied by total distance and an upward force multiplied by this. So ROA, our ROE is minus 126.67 multiplied by 2.8 plus what? Plus ROD. Our ROD is what? 468. 468 point what? 0.893 multiplied by what? 1.4. All right. So if you do your math, you are going to have the bend moment at point C to be equals to 301.77. All right. So now the next one is bend moment at point B. All right. The bend moment at point B is this. So if you stand at point B, we are going to have this multiplied by the total. So we are going to have minus 126.67 multiplied by the total distance to our B is going to be what? It's going to be 1.4, 1.4, 1.4. That is 4.2, right? So we are going to have 4.2 here, then multiplied by, sorry, not multiply, then plus what? Plus ROD. What is our ROD here? Our ROD is nothing but what? 468.10. 468.893 multiplied by the total distance here is going to be what? It's going to be 2.8. 2.8. All right. So this one is a downward force. It's going to be minus 300 multiplied by what? Multiplied by 1.4. So if you do the math well, I'm going to have this to be nothing but 360.8864. All right, so that's what we are going to get. So the last but not the least is the bending moment at point A. So the bending moment at point A is going to be equals to what? 0. All right, so if you want to do that, you can still start at this point, then you take your moment towards this side. So it's going to be what? 0. All right, so the next thing we are going to be doing is to draw the shear force diagram and the bending moment diagram. So for us to do that, we are going to be drawing our straight line down at each point that we have what? Load. All right, so we are going to be drawing the shear force diagram. Now for the first beam, this is the first beam. So here is all our shear force calculations that we did. All right, so here we are having the shear force at point H. The shear force at point H is what? 213.33. So 213. So let's just check for the highest value there first. So I think 213.33 is the highest value here. So let's raise it up. Let's make it to be at this point. So that is the point. So and between point H and G there is no load. So we are going to join this load. We are going to draw a constant line. So let's join this line down. All right. So that's it. So now the shear force at point G now. The shear force at point G is what? Minus 86 point what? 67. So let's make the point to be here. So this is don't forget that above this line is positive line and below is what? Negative. So we are going to join this point to this point. All right. So now between G and F there is no load. So we are going to draw a constant line. All right. So that's it. All right. So now and the shear force at point F. The shear force at point F is nothing but what? Minus 126.67. So we are still going down since what we have here is minus 86. So we are still going down. So let's put it at this point. All right, let's put it at this point. So coming down here. All right. So between F and E there is no load. So this is it. So now at point the shear force at point E is 0. So we are going back to what? To 0. All right. So this place is our positive. This is our negative. This place too is our okay. Let's just put it at the center. Let's cleanse part here. So this is negative. All right. Now let's go for the second beam. All right. So for this second beam, we have the shear force at point F. Sorry, point E to be what? To be minus 126.67. So don't forget that we have the list number here is minus 126.67. So and which is this point here. So it will be at the same line with this. So let's just use our ruler to trace that out. So minus 126.67. So that's it. So that's our minus 126.67. So let's draw the full line. All right, and between point E and D we don't have any load. We don't have any load. So we are going to be using a constant line here. All right. So at point D, our shear force is nothing but what? 342.22. All right. So that's our shear force. So we are going up. We are going up, and I think that is the highest number here. So 343 and coming 343. This first one that we have here, it was what? It was 2, 3. So this 4 distance is going to be higher than that. So let's raise it higher. Let's put it at this point. All right. So point D. All right. So now between D and C, we don't have any load. All right. So let's draw a straight line here. All right. So now at point C, at point C, the shear force is what? 42.22. 42.22. So for 42.22 will be somewhere around here. 42.22. So let's draw this line down here. All right. So now between C and D, we don't have any load. So we are going to join that with a constant line. It's going to be a constant line. All right. So, and the shear force at point B is what? Negative 257.78. All right. This one that we have here, it was a negative what? It was negative 126. So this other one will be going more. It's going to be coming down more than this because it is higher than this. So it is not higher, it is lower, right? All right. So that is a minus 2. This thing. Let's just put it here. Let's put it somewhere around here. Let's just put it somewhere around here. Or let's shift it down a little bit. All right. So we are going to have this. I hope we are learning. So now, between point B and A now, there is no load. So we are just going to draw a constant line. So, all right. So now then we are going back to 0. Shear force at point A is what? 0. All right. So that's it. So we started from this point here. So this point here is negative. Why this point here is positive. Let's clean this. Okay, no need to clean. Let's just leave it like this. This is positive. All right. So let's just make it of this part. All right, that's positive, and this is negative. All right. So we are going to shade now. So we are going to shade this. Right. Okay. Shade this. Right. Right. So yeah. Yeah. I mean, so yeah. All right. So this is what we are having. So I think you can see everything clearly now. This is what we are having. All right. So now let's go for our bending moments now. So we'll be going for our bending moments. So let's check our bending moment critically well. So for the first beam, do we have any negative values here? The first beam range from H to E, from H to E. So this is our first beam. Every value is positive. For our second beam, it ranges from what? E to A. From E to A. All values here are okay. We have one values to be what? Negative, while the others are what? Positive. All right. So that's great. Let's shift this one here. Okay. All right. So let's start with the first beam now. The bend moment at point H is what? 0. So this point is going to be what? 0. All right. So the bend moment at point G is what? Is 298.666. I think that is the highest value for that beam, for that particular beam, right? Yes. And what's the highest value here? That is 3. Okay. So let's put this. Let's let our 298.62 to be somewhere around here. All right. So now we'll be using an inclined line to join this point and this point. Why? Because when we are drawing our shear force, every point that we have a constant line, we are going to replace that with a what? An inclined line on our what? On our shear, on our bending moment diagram. All right. All right. So that's it. All right. So now, and at point F, we have it to be what? 177. So which is lower. Which is lower. So let's put it somewhere around there. It is lower. So let's let it to be somewhere around there. All right. So that is point F. So we are going to use an inclined line to join this together again. All right. So at point E now, our bend moment is what? 0, right? So this is our 0 here. So we are still going to use an inclined line to join point to this line. All right. So this is our first beam, which is positive. It is positive. All right. So now let's go for the second beam. Range from what? E to what? A. So the bend moment at point E is what? 0. So this will be our what? 0. All right. So now the bend moment at point D. The bend moment at point D is what? Negative 177.38. All right. Negative 17, and it is the only negative value that we have there, right? All right. So we can put it to be at this point down, since it is the only negative value. So we are going to use an inclined line to join these 2 points together now. All right. So that's it. All right. So, and then the bending moment at point C is what? So where is our point C? This is our point C, right? This is our point C. So the bending moment at point C is what? Is 301.77. So 301.77 is going to be higher than the first one that we have here. This one is 298.66, the number that we have here. So now let's take this higher at point C. At point C. So let's take it to be somewhere, because it is the highest value that we have there. Yes, it is the highest value that we have. Oh, sorry, it's not the highest value that we have. The highest value that we have is at point B. Okay, so let's put it to be somewhere here. All right, let it to be somewhere here. So now we are now going to use an inclined line to join this point and this point together. All right, so that's what we are going to have. All right, so now at point B now, we have our moment to be what? 360.88. 360.88. So 360.88 is higher, right? So it's going to be at somewhere here. So we are going to use an inclined line to join this point to this point. All right. So now, and our bending moment at point A is 0, this point. So we are going to use inclined line to join this point to 0. All right. Let me follow this again. The bending moment at point point E is what? 0, and the bending moment at point D is minus 171, okay, which is this point. And we join these 2 points. Then the bending moment at point C is 301.77, so which is this point. All right, so we use this thing to join these 2 points together. The bending moment at point B is 360 point something, 0.886, which is higher than this one. So it's going to be here, then we join, then to 0. So that's correct. So here, the line here, this one here is going to be our what? Our negative side. While this one here is going to be our what? Our positive side. All right. So let's shade now. All right. So that's it. All right. Yeah. All right, so that's it. So this is our shear force diagram, and this is our bending moment diagram for this particular question. I hope you have learned a lot from this. Thanks. Stay